So much. Welcome to the stage. Super exciting topic, actually, but huge one. How do we train the next 1 million engineers? So as we said, we're going to find a solution to this problem today on stage, and then next year we're going to come back and talk about our awesome solution. Hopefully. So the first question that I pose is, what is the single biggest challenge in training 1 million engineers? Or what are the biggest challenge in kind of training these people in general?
You're looking at me, so I guess you want me to start.
Yeah, go ahead, sure.
Well, I just finished my presentation, so I would say the biggest challenge are teachers, because they're really conservative, reluctant in actually bringing new things. Especially if you say starting in kindergarten, then they are actually, in most of the cases, they are the barrier that's actually to having bringing the engineering education into early stage. That's what I was thinking.
I agree. I think I would have said fear is the biggest barrier, because it's kind of the same reason. Teachers are afraid. They don't yet realize what their students are capable of. They've been teaching the same types of things for so long. They feel like they know what their students can do and can't do. And yet, when you incorporate this type of stuff, students are constantly surprising their teachers. So if we could just get the teachers past the fear, I think that there would be a lot more of a smooth path ahead.
Yeah, so picking up from what Kiki said, I think enabling a progressive ecosystem with the conventional methodology which is in place. So we have math, science, languages, which is imperative. However, if we put in different methodology in this, such as artificial intelligence or robotics, or I think virtual reality classrooms to make it fun for the kids to learn, and also for the teachers. So yeah, I think I could start with that.
Yeah, for me, I feel like, because I don't come from an engineering background, so I would probably say that the future of generation, in my imagination, would probably like not limit just to engineering itself. It probably include a lot of other subjects. It's how can we actually bring all those concepts together? No matter it's engineering helping others or others helping engineering. It's how can we bring all those things together to make it happen for the next engineers. Yeah, in a way.
I think, at least in the UK at the moment, the biggest barrier is the perception amongst policymakers about what is academic rigor. So they redesigned the whole UK education system, trying to reintroduce. They felt that this idea of academic rigor had disappeared from the curriculum, and it needed to be reintroduced. And what it basically meant was that it's almost impossible to do project-based learning in the UK education system anymore. And in a way, I don't think it's possible to teach engineering without doing project-based learning. Like, fundamentally, that's and it's such a great way. It can then be such a great way to teach everything. Like, as as everyone was saying in their talks today, that the process of engineering something as a project with a load of kids in a school, you can bring in all the other things that are on the curriculum. But if you've decided that the only way that kids are getting a proper education is if they're going to go and sit down and do a 3-hour exam at the end of it, and that's how you're going to grade them, then we're not really going to be able to teach them engineering.
So then there's a couple of issues to face there, I guess. But the first one, and maybe the largest portion of the panel said, was this fear that teachers face. And so I'm curious, could you elaborate on is it a fear of lack of knowledge in those spaces in particular? Is it a fear of just of what's new? Is it?
If you think about educators, many of today's educators, as they never had to learn computer science as a child, right? They learned math themselves, they learned reading themselves, and all of those other fundamentals. So to some degree, they have a comfort around it, and they think they understand how it's supposed to look and how it could be taught. But with computer science, engineering, and many other technical programs, they never experienced that themselves as a child, and maybe not even as an adult. So they don't know where to start, and it's just a big unknown.
And also, we've seen the education system, and I can speak about it for the Asian and the UK market because I lived in the UK for a few years, that the schools, the kindergartens, monasteries are making an effort, and even for primary education, the effort is being made to do project-based learning, like you said, or give them Lego to build something. So I think the starting point is there to a smaller percentage, which again ropes in back to problem-solving skills and the very basic of AI or human interaction is pretty much in place. But like you said, there is that fear to sort of go full throttle with eradicating textbooks and just replacing it with a classroom that has only Lego or sellotape and just blocks, or they just playing around in the garden saying, okay, I know what A for an apple looks like. So
I think it's important first to say, like, we're not trying to blame all those teachers, especially in the current. It's important too because we keep saying teachers are reluctant in the new technology, but imagine that everybody is actually quite difficult to make a change. And in the past 100 years, our educations keep trying to do the same thing, and we're actually at the point that we're trying to change it, and that's the reason why they have this big fear about it. And on the other hand, when we're looking at the teachers throughout Europe, at least what we contact is especially kindergarten or elementary school teachers, their way of becoming teacher is very different from high school. They are not engineers at the first place. And they becoming teacher from, this is not, I'm not trying to generalize it, but most of the situations they become teacher because they don't want to study other things and they want to be with kids. So based on this, and imagine that they actually now have to learn something that at the beginning they choose not to learn, and further they consider this has to be something as responsible for the education, so they have to own the knowledge for transferring the knowledge, and that creates a big fear out of there. So I think that's also the place we should look into to solve it.
So when we talk about fear, there's kind of the assumption that some sort of change has to happen, that one thing has to disappear and a new thing comes, and that's the scary part. So what isn't working now, and what is it that has to take its place if we want to train 1 million kindergartners to be engineers?
Yes.
When I mentioned in my talk that any entrepreneur will tell you you have to be comfortable failing. And the current education system, at least in the States, is not okay with failing. They don't allow for failure and recovery as well as you would need to be able to in order to really get in there with engineering and become comfortable with engineering. And if you can imagine a school system teaching engineering in the same way they teach mathematics or in the same way they teach grammar, where the first time you're wrong, you get marked off and that's your grade, and you might be able to retake it if the teacher is nice. You won't ever learn anything. You won't get that opportunity to fortify yourself, and you will see yourself as a failure. In order to bring that type of education to schools, the entire thought process around what is success needs to change. And that's on more than just the teachers. That's on the entire
Community.
thing. Yes.
Yes, sure.
Yeah.
Yeah, I think I totally agree, and I think what we should focusing on is that we're not lack of tools anymore, and we know all the technologies, they are all existing, and in educational markets there are so many products existing, but we see very big influence from policies that the government has to make a change, that they also need to be aware of that. And the other things is basically about how we facilitate or change, make sure the teachers feel comfortable about the change, which means from industry side, from platform providers, we have to be thoughtful, not just about products, but everything beyond the products, until teachers can just take it and use it in the classroom and they feel they can accept this thing. That will make it much easier for them to.
Yeah, and I was reading about how successful the mother-toddler programs are these days, where you take a 9-month-old into a kindergarten for a mother-toddler program. And so everyone just sits around and sings and dances, and, they have placard learning. And the mothers of these babies versus the ones who don't go for the mother-toddler program often have a perspective that I think my child is learning and picking up things quite faster. So when we're talking about just kindergarten at the moment and 1 million as a number, even if we get to proof of work for the interested global kindergartens, to probably have a flexible methodology, however, keep the enablers fixed with regards to language, colors, and everything else, But when it comes to the mandatory things for an engineer, for example, maths and science, probably they could start it at an early age in a very fun learning way that retains in the mind of a child, and it helps him grasp things better. Like me being an IT graduate, I did it only because my parents wanted me to do it, and I hated it because I went through like thousands and thousands of pages just to learn how to code or how to program.
Yeah.
And I didn't want to do that. Like when I look at kids now building these amazing bots, a 5-year-old is doing it, and he wasn't made to read because he can seldom, speak a sentence, but he's built a bot. And, I would have loved to do that, but hey, I think that ship has sailed. But it's time that, people can sort of learn from this.
Yeah, I probably have another approach addressing the question is that I feel like as human beings, because I always don't know what I wanted to do, and I don't really know what my pros and cons are, what I'm capable of through all these years from growth. I feel like probably most of the teachers, they share the same idea too. They just coming out of nowhere, become a teacher. And it's, we all know that curiosity and those passions really drive people beyond their ability, like the entrepreneurs that we see here. So why don't we take the same concept in a way to really ignite the passion and the interest for them, not as teachers or students or whatever they are, as humans, that what you want to do. Are you really love engineering? Or if you don't like engineering, can you use engineering to pursue a passion? That could probably, detouring, but also a fundamental way of, hoping to solve that.
Yeah,
And yet it's really difficult to grade
is,
passion,
yeah.
right?
Yeah, and it's
The-
really hard to how to
You
say.
can't talk passion with teachers usually because they're super booked.
I
all the
know,
time.
it is,
Yeah.
it is.
Yeah.
But I mean, it is very important. I think inspire them with all the passion and love about engineers. It's just that they also don't have time sometimes. So from everybody has to work all together for that purpose to help them to feel comfortable with it,
Yeah.
and then they will start to love it, and then they can further bring it.
I mean, I think another thing that's kind of maybe often overlooked, I guess, is the importance of actually making engineering visible to children, because it isn't generally very visible in our culture. We see the results of engineering, but we very rarely see actual engineering happening.
You're
And
absolutely
this idea of the importance of failure to engineering. Obviously, when you're an engineer, you know that you're failing all of the time, and then eventually, right at the end, you get it to work. But that's not how people, I think, generally perceive what engineering is, because all these perfect products come out at the end. And Akram and I were involved in making this TV program in the UK, where it's a group of us, and we build one-off bits of technology to solve problems for different disabled people. And so it's quite a good narrative, because you've got characters that people can get their head around, and the user is embodied. But also, most of the program is just us doing stuff that doesn't work. And so, yeah, lots of my friends who are teachers, saying that they're showing the program to the kids, because it's a really good way of explaining what the process actually is.
Yeah,
So-
and we've all learned things in school and universities which we don't apply necessarily at all. Like, there are a few algorithms, but I still don't know why the pi was there, So there were a lot of things that were taught to us which weren't really of any particular use in today's world. So when we talk about engineering versus following what the child wants to do as a passion, but since we are moving on such a full accelerator speed with space, artificial intelligence, and everything to do with it, we would, I think, need those many people, at least with a basic foundation. For example, if you want to be a doctor, you need to understand science. So similarly, in these fields, I think that the foundation of engineering would only make it stronger. And then, like the previous panel said, that we are looking at hiring people in the space job industry who don't particularly come from the same ecosystem, which, but I know that engineering is a great foundation to at least build your creativity and aptitude.
Interesting.
We almost forgot about you.
No, that's good. That's the whole idea. I'm not the important one here. You mentioned briefly earlier, actually, I think it was you that mentioned the idea of policy and government and this sort of thing. And I wanted to pose the idea that maybe it's not up to government or schools or universities at all to educate the next 1 million kindergartners, but that maybe it comes from private entities or opportunities like Robotex, for example.
Yeah.
And I wanted to present that as, I guess the question really is it up to government and policy, or is it up to the will of the people and the private sector?
I think it depends on which level of education. So if we're talking about kindergarten, elementary school, or we're talking about the normal education parts, policy plays a very big role. Like we said, teachers are usually fully booked. They're not fully booked by the kids or by us, by industry. They're fully booked by the government curriculum schemes and everything they have to do at the school, and they have to correct everything. They have to do for example, a lot of countries, the only way to do exam is on paper to write things. That's not a proper way to teach, for example, coding. So we see a lot of changes in countries if the governments do make the policy efforts on the STEAM education, then the country really becoming very, very fast. Like, for example, in France, because of the policy push, our robots is actually in 6,000 schools. And they all use this actually teaching coding. But if you look at Germany, all the policies are very slow due to all kinds of reasons. And then the whole coding education is actually very slow and very behind. And then you see a lot of efforts from industry trying to go around the governments and put the robots or coding tools into the schools to do this education. But that sense usually influence to like a high school or university. So for a very low, like an early stage of education, I think policy is very important force to drive there.
Yeah, and it's very tempting to circumvent the school system because the school system is so difficult to work with and say, well, actually out of school is a lot easier. So if we start with out of school, we can really do whatever we want and bring this to as many people as possible. But then you start to create this digital divide because not everybody can do after school. And even if a student has the ability to be there and their parent can come pick them up because they missed the bus because they did the after school, their parent might not actually believe that the student can do it or might try and save the student from the embarrassment of experiencing these stuff. Whereas when you embed it in the school day, everybody's getting an equal opportunity and you're reaching the exact same kind of composite of people that exists in that neighborhood. So you really don't have an issue with race or gender or any of those things. Everybody's getting it. And that's how you make sure that then everybody feels comfortable taking it at an older grade, even though it is so much easier to say, let the school have what they want. The tech billionaires will fund this after-school institution. And then having the tech industry involved in it creates its own set of feelings towards parents and policymakers.
Yeah, and it's also majority of the times we've noticed that it's the private sector which will come out with something creative and state of the art, need of the hour, and then the government will, give a thought and say, I think I need computer science in school. Robotics is not necessarily a subject, which is an official subject that a government agrees to. However, 80% of the schools are, I saw 100 kids from India, and I was like, really? Wow, how did you find out about this? And they said, we've been learning robotics for 5 years, and that coming from India, I mean, if it was, American kids, I'd be like, okay, explains. But it's really a huge gap and a challenge that the government will only look at it after it's been really, really successful. So it's quite a chicken and egg, but, they will come to it later. And especially, talking about Asia, when a private sector develops an airport, and even in Estonia, Ülemiste cities made the airport versus a government airport, it's state of the art. So that's what I feel.
I kind of highly echo what you just said. It's sometimes, it takes the private sector to really do something.
Yeah.
Or act first, and then kind of have this milestone or have something to present, and then the government kind of suddenly realize, okay, so this is happening. And then I really just, they also wanted to take it easy.
Yeah.
It's like, okay, so you already lay a fundamental thing, so all I need to do is just wave the magic wand a little bit, and then everything will be set. It's, in a way, really. And the thing that we see in China is, interestingly, the same trend. So, in China, because we use the concept of maker education, so computer science is already a subject, like a compulsory subject, back in 1990. Yeah,
The same as in
China.
India as well.
Yeah, but it's just about, Word or Office, those, and data, and about, those things. But robotics and those maker sort of stuff was never there. In coding, never there. So some of the computer science teachers, so they are the group of core leaders, sort of like the push 4 years ago to really, we want to make something else happen. We don't want computer science as what you see right now. We want to make a change in this subject. So they collaborate with corporate like us, different, companies, private sectors, and then we kind of make it like a prototype of, working together, sort of, if you put it. And then the government step in, putting all those monies, putting policies, saying we put maker spaces, and that's how this thing grows. At least the thing that we see in China.
Yeah, and also what I've noticed is that everyone who's in these progressive fields and breathes in that ecosystem is also very passionate about what they do.
Yeah.
I mean, a robotics coach is very passionate about what he's doing. And when we look at a school teacher, we see that they've been teaching or coaching the same subject with the same textbooks for at least an average of 5 years. There isn't a change as such. I mean, we all know the basic education needs to be the same, but after a certain point, I think after 5 or 6 years of age, there should be a variety in what you're learning, and especially in sciences and, civic. Maths pretty much remains the same. So yeah, I mean, this field is so passion-driven versus the conventional field, and I think it's only the kindergarten stage where these two can sort of come together and the jigsaw really fits.
Awesome. So I want to jump right to audience questions so that we... let's take this one first, because you asked a question earlier. Try to get as many people as humanly possible.
That making engineers out of kindergartners, have you considered about the development of the brain and the development of the mind, that it's the development of the potential, what can you even learn during some ages? And if you're saying like the last thing that was said, for example, about making it more varied from like after 7 years of age, then that's, I'm sorry, but this is bullshit. You can't do it yet. Yes, you can do some playful acts during that time, but the brain is more ready for abstract concepts when the child is around like 11, 12, from that moment on. Before that, that's where you get the basis. Please.
Do you mind if
The
I ask, are you a
basics.
teacher?
No, I'm a psychologist.
Okay, because that's the kind of
Definitely.
stuff we tend to hear from teachers.
Everybody wants.
I really want to jump in on this. Sorry, I totally disagree. Like being an engineer is amazingly like being a kindergartner, actually. Like, so they're all already engineers. The whole way that they're approaching the world and the way that they're going about things is actually the way you need to go about things to be a successful engineer. And actually, most of the school unteaches that
Yes,
stuff,
exactly.
takes it away.
Yes.
And that then when you actually have to be in a job where you actually have to make things, you have to relearn all of that whole approach that you had when you were a kindergarten. So it's like we don't actually need to, it's more about how do we keep them as engineers
Yes.
as they go through school, not how do we make the kindergartens engineers, because they're already engineers.
The
Right.
important part isn't what is a function or a triangle is one of the strongest structures that you can use. The important part about becoming an engineer is I believe that I can try again. I believe that I can do something no one else has ever done and that it might still be possible. I'm going to try these things even though I'm afraid and I don't know if it's going to work. And I'm going to research and try and figure out or try various different methods until I get something. It's really that creates an engineer rather than the knowledge that they'll fill in through the rest of their life.
And I'm not frightened of trying something that seems stupid. Like, that's so important.
Yeah, and also when you said that, what about understanding the signals that comes out of a child's brain? Well, I think that is great, and I'm sure artificial intelligence can help there. But when you're looking at assessment criteria in schools at the moment, it's assessment based on the subjects that the child is studying versus 0 to 5, there is no real assessment on subjects because there aren't any subjects. So I feel that, yes, it's amazing that we are able to map those signals, but at a later stage. At that age, they would anyway give away signals in a much more vocal way because their emotions are really straightforward versus our emotions to be coded and then read.
So I want to give you the opportunity to respond quickly.
So what I get is what you mean really is that to prepare them to be able to become coders and engineers and stuff like that, so that they're learning in playful ways, they're getting to know the basics and everything, but not forcing them to actually like code like in a hard
Absolutely.
way.
Yeah.
The worst
Yeah.
thing you could do
It
for a
is.
student at
Sports,
any age is
yeah.
force them to get to be an expert in
Yes.
something before they're ready.
Yeah, engineering is again so varied, right? That it
Yeah.
doesn't necessarily have to be coding
Like
or
building
programming.
stuff.
Yeah, there's automobile, there's machinery, there's mechanical, there's mechatronics, there's a whole bunch of it. And in those 12 sort of categories that engineering has, I'm sure that the child would be wanting to pick either one of those, or then none of them. And then we know that hey, let's not train them to be an engineer.
The
Great
best
question.
way to learn any kind of engineering science is to want to make something that you need to learn that science to be able to make or make it better. And then you're actually motivated to learn it. And if that's so much easier than saying, okay, now you learn all this science, and then once you've mastered it, then we're going to let you make something. Like, you're not going to be interested.
Let's jump to the next question.
So actually, two questions, just taking the spot here.
Pick one.
I fully understand the importance of failing as you're making, but as educators observing the kids, how do you evaluate, by what metrics do you evaluate the, say, quality of failing? When it's a nice failing or when it's a bad failing? The first question. And the second question, which is kind of a curveball. So we talked about kindergarten, but the actual, say, problem of digital divide today is not necessarily with kindergarten, but actually with middle-aged men. Mm. And so how are there ways that you develop that could actually be used for middle-aged men?
I think with the first question, failing, that thing I think it's high time that everyone takes that out from the books. Is it a good failing or a bad failing? It's maybe a child is not able to grasp one part of the subject or the matter, but then there's the other side to it as well. So if it was me, I would just pretty much take out failing and look at it as exploring another side of it.
And I would actually say that there's no such thing as bad failing.
Yeah.
There's bad
Yeah.
trying again, right?
Yeah.
educator tries to orientate, not talking about the kids, and maybe the kids doesn't need to know, but really for the educator, the teacher, in the way he's going to evaluate his own work, and
Right.
for each individual, how can you orientate?
I think if you're trying to be an educator, that you're trying to examine everything and really puts outputs like a graph all of there, and then that's very old-fashioned way in the current education, and that's also a problem there. I think educators should be a facilitator. So the output is not that important. That if he actually remembered 1 + 1 is 2, but the process that you guide him to try how does it work is the important part.
And it doesn't have to be the output. I'm talking about the process, indeed.
Yeah, that's the process.
Yeah, and I think the big deal is really not what they come out with, but the big concepts behind being able to look at their persistence level, their teamworking level, the skills that help them in the long run. Unfortunately, our systems aren't built for assessing those types of things. And unfortunately, the real creativity only comes when you're not afraid of an assessment you're going to get. So we really do have a long way to go with that.
And on that note, thank you so much, panelists. And thank you so much, audience.
Thank you.